Hello, everyone. Welcome to Devtoberfest 2024 Week 3. My name is Ajay Soreng, and I'm your host for this session. The topic for this session is transforming legacy code to CAP with help of GenAI. We have our speakers Mamta and Ajay with us today for this session. We Please feel free to ask your questions in the chat, which will be answered by the experts. Without further ado, I would like to invite Mamta to introduce herself and take us through the session. Over to you, Mamta.
Yeah, thanks, Ajay. Yeah, hi. A warm welcome from my side to the session, Transforming Legacy Code to CAP with the help of GenAI, myself, Mamta,
Excuse
and
me,
also
Mamta, we
along with
cannot hear
me.
you.
Oh, hello, how about now? No, I can't hear you.
Please go ahead, Mamta.
Can you hear me?
Mamta, you can start, please.
Yeah, one second. Yeah. Mm, Sorry, there was a glitch. A warm welcome to the session, Transforming Legacy Code to CAP with the help of GenAI. Myself, Mamta, along with me, my colleague Ajay Sima is also there. We both are from BTP engineering team. Before get into the details of how legacy code can be transformed to CAP using this GenAI tool, let me talk about the migration process and why this migration, and also what are the challenges with respect to migration when we do the migration manually. Yeah. Yeah. When we look at any application generally consists of three layers of object, the DB layer objects, and then service layer, and then UI layer objects. So the migration happens for all these layers of objects from the source technology to the target technology. So why the migration is required. So as Neo deprecation is announced, customers who are running their access-based applications running on the Neo platform, which they want to migrate to multi-cloud, they should also migrate their access-based applications. And also customers who would want to move from on-premise to the cloud, they would also need to migrate their applications to the multi-cloud. So when we talk about the DB layer artifacts migration, DB layer consists of different types of artifacts, that is tables, calculations, views, procedures, and functions. If you look at these, database artifacts migration, that also consists of, design time migration as well as runtime objects migration. So for the DB layer objects migration, if you see the 6 months back, the situation was there was no tool available for the Neo customers who wants to migrate their classical HANA DB artifacts to the HANA cloud. And since classical HANA DB supports different types of objects, there are some object types. Those are some of the object types are not supported anymore in the HANA cloud. The user has to spend lot of effort in migrating their unsupported artifacts to the supported. So this is one of the challenges when you talk about the migration of DB layer artifacts from classical HANA DB to HANA cloud. Coming to the service layer objects, again here Service layer objects consist of, in case of XS application, we have xsjs, xsodata, and XS library objects that needs to be migrated to CAP, CAP in the CDS and then OData. Again, here the migration would take a lot of effort, because here we talk about two different application programming. In case of the classical XS application, we talk about XS programming model. In case of CAP, it is a cloud application programming model. Some of the cases where we have to, though we say it is a migration, some cases we need to rewrite code entirely. This would take lot of effort from the person who is involved in this migration, as well as the person who is going to migrate these classic XS based applications to CAP. That person should know, well aware of these application programming model and also the framework that is required. So this would take lot of effort if they want to migrate these XS based applications manually. So coming to UI layer objects, if the technology is going to be same in case of the target technical stack side, they can migrate UI layer objects with minimal effort. So in today's session, we will talk about how tool is going to help migrating these HANA DB artifacts as well as service layer artifacts. So I will talk about this HANA DB layer artifacts migration, and my colleague Ajay will talk about how this GenAI tool help the migration of service layer objects. Yeah. The solution which we have currently for the HANA DB migration here is, we have a BAS-based extension that is called SAP HANA Application Migration Assistant, that is released to customers in Q2, which is available, that can be used to migrate your classical HANA DB artifacts to the HANA cloud. And for the service layer objects, which will be released soon, this is again a GenAI based tool. It will be integrated as part of our BAS extension. This tool can be used to migrate our xsjs and xsodata, XS library to CAP, and the OData service in CAP. So coming to SAP HANA Application Migration Assistant, as I mentioned, this is a BAS extension. This can be used to migrate, XS classic applications to the SAP HANA Extended Application Service Advanced Programming Model or Cloud Application Programming Model. So currently we have two templates. One is, to migrate XS Classic to XS Advanced. And also with this, we will also migrate to the asynchronous XSJS application. And also we have another template called XS Classic to CAP. Here all the classical XS based applications will be migrated to CAP compliant, and along with this HANA Cloud DB, classical HANA DB artifacts will be migrated to HANA Cloud DB artifacts. So in the coming we would be having another template called XSA to CAP that will be released soon. Maybe in another couple of weeks, we would be releasing another template which will support the XSA to CAP migration path. The overall SAP HANA application migration assistant solution diagram looks like this. How we access this, the application HANA application, SAP HANA application migration assistance. So first thing, you should have an subscriptions to SAP, Business Application Studio, and whoever has the required role to access the Business Application Studio, they would also get this SAP HANA application migration assistant extension. The authentication of this is done via the identity services, which is part of our recipe BTP sub account. And all the source DB systems will be connected or exposed via the cloud connector. And these systems will be connected via the destinations. And With this SAP HANA application migration assistant, user can select the required template. Either it could be XSC to CAP or XSC to XSA based on their business use case, and then they can migrate their applications to the desired target. And then once the migration is successful, they can also deploy their applications to the the target HANA DB. This is the overall, the solution diagram of our SAP HANA application migration assistant extension in BAS. When we talk about the SAP HANA application migration assistant, there are some prerequisites that are required. First and foremost is subscriptions to SAP Business Application Studio, and we should also have Cloud Connector installed. And we should configure this Cloud Connector, and where we access or expose our the source system via this Cloud Connector. And also we should have a migration user connected, created in the source DB. And as part of our SAP BTP account, we should create a destination with parameters that is especially the web ID usage equal to xsjdb. If we don't create a destination with this parameter value, then we won't be able to access the systems which are exposed in the Cloud Connector. So these are the the prerequisites that are required to access our SAP HANA application migration assistant. So I quickly show how this tool looks like. Yeah. So once we have access to, once we have subscriptions to the, SAP Business Application Studio, you can, launch the Business Application Studio from your BTP sub account. And once we are launched the Business Application Studio, we land up here, and then we should create a developer space. Like I would create a demo dev. Okay, here you can see the list of extensions that are available. So in our case, we need to select this SAP HANA application migration assistant. Once we create a developer space with this extension, this extension is available in this particular developer space where we can, start the migration. So it will take some time. So I'll just quickly open the developer space, which is already been created. So here is my dev space, which is created with the extension SAP HANA application migration assistance. Once we come to our dev space, here is the command that needs to be run, SAP HANA application migration assistant. Yeah. This is where we can see the two templates which are supported. One is XSC to XSA, another is XSC to CAP. Now I'll select this XSC to CAP. And here is the list of destinations, the list of the source systems which are exposed. I would select, this is the Neo system which we have exposed via the Cloud Connector. I will use the migration user. And we need to authenticate this user. Once user is authenticated and logged in successfully, we can go to the next step. Here is the list of the objects. Here we support two different types of objects that can be taken. Either it can be a delivery unit or it is a package level migration. So now I will select delivery unit, and then say I'll give my LM. And you can select the target directory where you want to migration projects should be created. I'll keep it under the projects only, and this is the target project name. I would share demo, and then click on finish. So here in the output you can see what is the migration that is happening. You can see all the logs are here in the output. It will take some time to migrate. During the migration, what exactly happens? So during migration, we take the selected delivery unit. We analyze these delivery units, and then objects will be migrated. So during the migration process, we will not touch any objects in the system as such, and only the activated objects will be migrated. So if there are any objects which are not in the active status, will not be migrated. Yeah, I can show here. Yeah, this is the Shrine application which was migrated. You can see all the DB artifacts that are gets migrated. We create during the migration. All we will convert our HDB CDS into CDS. Even HDB functions, tables, calculations, views, everything will be converted here into CDS. And generally for the calculation views and HDB functions and tables, we create a proxy objects. You can see here for HDB functions. These are the proxy objects. That means we don't create exactly these functions in the runtime, but we make during the modeling time. We can say that these objects already exist in the runtime. Just we will would use it as a proxy. Yeah, similarly for the calculation views also, all the proxy objects are created. And once the migration is successful, there will be a report generated where you can see the report.html. I just kept it open. In the report consists of all the details about, what are the migration steps that are involved, starting from the preparation phase till what are the supported objects, discontinued objects, how these xsjs migrations that are migrated. Along with that, since I selected this xse to cap migration, you can also look at how these objects been migrated to cap. Yeah, you can here you can see the list of objects that are migrated from HDB CDS to CDS, all the HDB DD files, and the calculation views, and also all the details are available here. So you can also, since this tool is already available you guys can try it out, and you can do the migration of your classical HANA access based DB artifacts from on-premise or Neo to the HANA cloud running in the multi-cloud. This is the tool. This can be used for migration of HANA DB layer artifacts. Yeah. With this, I will hand over to Ajay to talk about how this GenAI tool can be used to migrate the service layer objects. Yeah. Yeah. Over to Ajay.
Thanks, Mamta. Yeah, I'm audible, right? So let me share my screen. Please let me know if you're able to see it. I hope it's visible, right? So yes, like Mamta summarized, I mean, like from the service layer, what exactly are we targeting about here, right? So I mean, like we talk about three key artifacts. I know that there are a lot many more, like access privilege and stuff like that. But what we targeted is basically the first one is access for data. I mean, this model is a pretty easy for developers made model where basically you have a DB, and then using access for data, you can expose your data, right? And then you have basically xsjs, which is server-side JavaScript, right? And then if you need any utility functions or you need some business logic which has to be written, that can be done in xsjs lib. So these are the three key artifact types which right now we are dealing it with. Okay. And good part is basically if you have a UI, basically, right, you can call this access data files as well as xsjs files from the UI. And also, for example, for the utilities part, actually, For example, if xsjs needs to call xsjs lib, that is possible. And then, for example, if you have some um, custom exit handlers which has to be done in xsodata, even that is possible to call xsjs lib, or it can even call procedures basically. So to put in a gist, so these are the three key types of artifacts which we are dealing with. So for the demo purpose, what exactly do we have it? So as usual, I think most of us or most of you know Shine, right? SAP HANA Interactive Education. So I mean, like this is the application which we take it. I mean, why we chose Shine? Because Shine is comparable, or it's like it has a lot of features first of all, and then it's pretty comparable to a typical customer like scenario, a customer product actually. So which has all these artifacts which we talked about it, right? So this is what we do it. So how do we do the demo? So just I think you can see my terminal, right? So it's pretty simple. Just a minute. So what do we do is that like we're running a simple Python script by taking what is a source. That's why we call it, that's where I'm just giving it XSA version of Shine. Okay. And then -d is destination basically, where the converted or generated artifact should be kept, right? And then the last argument is DB, like the path where the directory which consists of all the DB artifacts basically, which are already migrated. Right now, this is still in development. So what we do is that like we just go here and then sort of do it, right? And then this is the way to invoke the SRV migration script basically. Okay, so this is pretty simple. So to make it simple, behind the scenes, uh, engineering happens. So let's look at that. That's a bit interesting. So let's go back to our Scalidra, right? So how do we do it, or how do we start about this? So simple. When we took this use case, so what do we do is that like how do we do it is basically using SAP BTP AI core services. It's pretty easy to find this. If you just go to Google, or if you just search for SAP AI core services, you will be able to find this. With this, what you can do is you can deploy your own LLMs, which SAP has partnered with a lot of partners like Azure and stuff like that. Okay. And then how does the interaction happens, right? So we also, like SAP also released a SDK which is called as GenAI Hub SDK, okay, which is a nice wrapper and gives you a pretty good like pretty nice way of interacting with the LLMs basically. So using these two, how did we start? Simple client with this SDK, and then we pass on artifact by artifact, and then at the end we use basically Azure's OpenAI LLMs. So the pretty first question which comes to our mind basically is that whenever we talk about these Gen AI projects, is that like, are we develop are we developing a new model, right? Or like, are we training existing model, right? So at least as per our evaluations, what the good part is that like there's not really a need to develop or train a model basically. Like LLM is well aware of be it be XS or XSA sort of artifacts, as well as the target, basically the CAP layer as well actually. So that's a good advantage which we have it with a lot of LLMs. And for our usage, we chose basically GPT-4o, which is latest from Azure OpenAI, right? And then like, so far for our experiments are concerned, basically there's no really need for, even at the moment at least, for techniques like RAG and stuff like that. Like with with uh, with nice orchestration and pretty good prompting, this can be achieved, right? Now when we tried this out, we also faced some challenges basically. So the first challenge which we faced is that like um, LLM has very limited context on when we pass on file by file. For example, assume a scenario where xsodata is calling xsjs lib, right? Or basically, xsjs is calling xsjs lib. And then we are doing this. This is not complete. Please keep in mind, this is not complete new generation for the use case. This is migration basically. I mean, like, this is more like to make it apple to apple, so that like for customers, they can still use the existing UIs and just map the service layer accordingly to the newly generated services. So that's an idea actually, first of all, right? So when we pass on this ones, so it has very limited context, due to which it used to miss some imports, hallucinate some functions on its own, and stuff like that. So these are the challenges which we faced it initially when we started with this part. So to overcome that, what we thought of is a nice way, basically, that how about if we give more information or more context on the artifact which we are dealing with LLMs. So that's the thing actually. So how do we do it is the question. So first of all, how does it look like? Let's go into that. All right. So typically, what we call this process as classification. So how does it look like is something like this. For example, if you have an artifact, right? And then, I mean, like, what is it names? What does it name? And then in terms of import, what and all it requires, what are the functions which it defines, what are the functions it calls with its arguments, variables, everything actually. So this is, I mean, like, this is helping LLM a lot in terms of giving understanding more context, right, on the artifact, so that it can generate um, with less hallucinations, or it can generate it in a better way, to put it simply, right? So the question is, how do we do it? So the very first approach which we took it is basically using simple standard parsers, right? So but the challenge is that, like, this works well with the standard xsjs lib, right? But xsjs gives uh, pretty much weird, basically. And to handle that, we used to start writing regexes, which is not a good approach, right? So what we then shifted or migrated is basically, why not basically LLM itself does the classification. So that's a thing which we do as a first stage. For example, the moment we take the source code, right? We do it step by step, or like file by file. Do the classify, let LLM classify it and generate. Now LLMs are capable of generating basically structured output, right? And with use of libraries like Pydantic, that helps, that makes the life easy, basically, to generate something like a structure JSON, which you see it here. So this with this, what we get is, we get to know more context about the artifact, so that we can pass it on to the LLM on the next run, basically. So that's simply it. So that's what we call it as classification. Right. So the second key challenge what we faced it is basically, this things works file by file for a smaller projects, right? Simple. So how to deal the larger ones, which most of you would have it, right? Or any customers will have it, large projects, right? So how do you basically modularize them? So that's where comes the key challenges. So what do we have is, if you look at this here, basically, how does for I mean, like, how does CAP provide standard mechanism or standard way of exposing these services? Is basically using service definition, the CDS, and then basically service implementation, in case if you want some I mean, like, along with basically your handlers, and then with be it be any custom logic with action, or be it be a function. Simple. So cap follow this structure. So how does, I mean, like, how do we use that in a efficient way to make this to be able to handle basically large projects? So that is where our modularization kicks in. So what do we do is that, or what do, after a lot of iterations, basically, what did we arrive at is something like this. If you look at this, right? Say, for example, if our structure looks something like this, right? So typically, I mean, like, with modulation, how does it look like is that, like, for all xsodata artifacts in one folder, basically, what do we do is, we create one service definition, one service.cds, and then its corresponding implementation, basically, right? And then, for example, this is the way, so that like assuming that customers who are already using xsodata from their UI, they can still follow the same route, basically, right? And then comes the xsjs part. So this is where bit of tricky comes into the picture, right? So because even xsjs can be accessed from the UI in the existing applications. So how do we do it is that, like, again, that in a folder level, assuming that, like, a large project has a lot of folders, so we consolidate, and then each and every folder for all the xsjs what it has it inside the folder per directory, what do we do is that, like, we simply um, create one custom hyphen service dot cds, which is a definition, and then custom hyphen service dot js, which is implementation. In this case of xsjs, in this case of xsjs, typically it could be mostly comes under the umbrella of like, be actions or functions, because like, this is a lot of custom logic which goes into the existing use cases, basically. So the problem simply doesn't end there, right? So because like, we are doing it bits and pieces, right? like, be it from OData or be it from xsjs, what we're trying to do is that, like, we're trying to achieve like a reverse engineering, basically. like, right. So still the core problem of how do you do the mapping from the database to this. So that's where we return some of, like, bit of orchestration to take the, like, be imports and stuff like that, actually, right, to be handled properly. So this is simple way of modularization, which we tried it with some projects like Shine, which is working good pretty well. Now the question is that, like, if you ask us, basically, the moment the generation is done, uh, can I deploy it and then test it out, saying that with cds watch or cds run? Like, that's a bit optimistic. Like, so that's because there's still some gotchas which we know it, which we are trying to fix it and improve it day by day. Like I said, this is still in development. And then also, the thing is that, like, the stuff which is generated, even though we typically run through, like, like, at least series of two chains of generating these files, basically, right? One for generation, one for optimization as well. Still we feel that, like, this can help you in terms of, or this can guarantee you in terms of up to 60 to 70% roughly in that area, in that region of, in terms of accuracy. The rest of the stuff, like, I think you as developers have to uh, manually instrument it a bit. So for example, examples are that, for example, like this namespaces, that's one thing, and then maybe the table names, right? Or maybe the parameters or arguments which you are passing it. Some things might not be wired properly in this whole, in the series of chains, basically. So those things has to be basically taken care manually. What we are trying to do also is that, like, we are trying to also, once this is done, so we'll also try to build some, like, give users some useful information regarding what has to be done manually, so that, like, it becomes, it makes your life easy in terms of going through them, and then, like, fixing it one by one, right? So we even try to we even try to do something with uh, automation with using agents and stuff like that, but that's a bit of too over engineering, actually. So which there'll be a point of time where we lose control on the generated stuff, and then, like, there'll be too much of hallucinations, basically. So to avoid that, like we said, so this is how the whole a typical this is how the typical flow works. For example, like, you have a XS or XSA project. Basically, first we do classification, classify artifacts, find dependencies, capture imports or exports, functions, variables, even the SQL details. Whatever we can get it classified from that artifact, we classify it. LLM classifies it, actually, to be open, right? And then we go into the generation state, where using this context, we pass it on with every artifact and the related artifacts, so that LLM has bit of knowledge, but more knowledge when compared to passing on artifact by artifact, right? Then what do? We do modularization and generation, right? And then after this, what do? Is also we do this import stage, basically, right? Fixing the paths and stuff like that from the where the DB artifacts lies, right? And then also we run optimization stage where we again pass it on and then say that like with prompting saying that like make it, I mean like generate it as compliant as possible to the CAP's best practices. I know there are a bit of stuff which deviate from CAP's best practices. For example, like if you assume cases like CAP recommends basically in a survey layer everything to be projections. Still, to handle some cases, we have to go with defining some associations and stuff like that even in a survey layer. For now, I mean like out of the box, right? So these things are some, I mean some things which I mean like which we have to take a note, and then probably, I mean, like if you wish to fix it out, you can even change that behavior, right? So this is typically in a nutshell how the whole flow works, right? So let's see what our guy is doing, right? So at the moment, this is if you just scroll it up a bit, nice. I mean, like the classification part is done, and then basically, it is in the stage of basically generation, right? It already got input related to the DB stuff actually, right? DB artifacts, and then now basically it will after generation, it's even optimizing it, and it will go on. So we even have other small um, problems related to rate limiting and stuff like that, which we handled it out with retries and stuff like that actually, right? So that's pretty much handled. Yeah. So what is right now? I mean, like what we cannot demo you is basically one nice report which says that like which has to be which requires manual attention or which requires basically uh, human intervention to go and fix it up or change it up and what needs to be changed. To that level, we are in development, and I hope we complete this by I mean like and make you I mean integrate with the existing DB migration plugin in BAS and then give it to you by before end of this year. So that's pretty much possible on the cards. So that much we can for sure guarantee that, right? So let's see how does it look like. I mean, like which we sort of explained it, right? So let's go and then have a look, basically. So what do we have it is that if you see it, right? So this is how the structure looks like. This is the output. I mean, like this is the classification JSON which I was talking about, which LLM generates it, right? So it's pretty much like what is artifact type, what is a key, what is a type. I mean, tokens for us just to get to know basically, like is this artifact too big for LM to handle it so that we can, we have some mechanism of handling them large files, really large files, right? And then if it has any imports, functions, SQL queries, SQL stuff, right? And yeah, I mean, like, is it a type of function or an action, right? And also, if it is, for example, xsjs lib, then where exactly is this called and stuff like that. I mean, like everything related to the artifacts is what this classification JSON captures it, and then using this, basically our orchestration layer will sort of pick it up and then pass it on to the LLM. I mean, like for example, like I said, I mean, like if an artifact calls something else, we also pick it up and then pass it to give LLM more context to make generation pretty much accurate, as accurate as possible, right? So this is how our classification looks like, right? And then comes the structure of CAP. I mean, like if you already know it, right? You have a survey, right? Which has, I mean, like I said, for example, if you take this big folder of this one from here, if you see it, right? So this is the old one. So which has basically core xsjs, it has lib, and then it has basically SAP HANA demo content APM, and then it has services, right? Which has a lot of xsjs lib, xsodata, all these artifacts, right? So how does it look like now? Is basically you have this, and then you have services, then you have handlers, which takes, I mean, like, which has uh, all your business logic and all your utilities will be there in the handlers basically. For example, and pretty much cap compliant, right? This is how the handlers look like, and then you will have basically the part of, I mean, like, this has, if you remember, this has also xsjs and xsodata. So all xsodata, for example, will be um, merged into something like this service.cds at this folder level. Okay, we even for to make it easy for users, we even give basically what is the source artifact and the relevant basically generation part, right, to make it simple, right? And as an example, for example, if you see this one, purchase or access or data, what does it do? It has basically association, right? And then also basically it has a custom handler for every create event before, right? So I mean, like, if you look at this, possibly, I mean, like I said, I mean, by textbook rule we should have all projections, but um, in these cases, I mean, we are defining even associations and or compositions if there are any, right? And then also basically this has a custom handle. So if you just go to, for example, service.js for this, so you can see that, like, I mean, like, as I said before, there'll be, I mean, like, on create event, uh, before create event, basically call this handler. So something like this, right? So this is how it looks like. And then, yeah, for example, come to the xsjs part. So typically, I mean, yeah, even these will be available for you, so that, like, this can be exposed. And I mean, I'm sure if it is exposed, there should be a logical reason for it, which does some business context or business logic handling the data. So even that is possible, or even that should be fine with this approach basically, right? So yes, so this is at least this approach works for a project of a decent size like Shine. In accuracy wise, like I said, if I just go and do a CDS run or CDS serve, I mean, like, watch, this might result in some errors for sure, which we are trying to improve it day by day. And then whichever possible, and then sort of, like, consolidate them, and then what has to be done manually, that will sort of put it in a report, and then give it to you, so that, like, you can developer as a developer, so you can just look into it, and then wire the things manually wherever is required. All right. So yeah, so that's basically it. So in terms of accuracy, we target somewhere around 60 to 70%, right? And then in terms of delivery, we're working with Mamta's team basically to see it integrated as soon as possible, and then even trying out to, to take this to some internal teams who can use this and give it feedback. I mean, and improve it instance by instance or day by day basically. So, and then make available for you by before end of this year. Yeah, that's mostly. So with this, I'll hand it over to back to Ajay.
Yeah, thanks, Ajay. And Mamta, for this great session. We had lots of detail through this demo and presentation. And I would also like to thank all the viewers who are watching us worldwide and who would also be watching the playback later on. And if you have more questions which were not answered in the chat, then you can also always go to the event page and then put the questions in there. Uh, these questions will be watched by the experts, and the answers to to them will be provided later on. So those links will be added also to the YouTube description of this video and also to the event page. We have also shared the link to the validation tutorial. You can attend that. You can answer those questions, and you can earn additional points for the Devtoberfest contests. So if you are not aware, this is a contest which is going on along with Devtoberfest, and the grand prize for that is all expense paid trip to next year's TechEd on-site in-person event. So even this year, the winners from the last year's Devtoberfest contest are going to the in-person event. So with that, I would like to thank all my presenters, Ajay and Mamta, and all the viewers online. And I hope you enjoyed the session, and see you till the next time. Thank you.